Good morning, everyone. Welcome to Midwest.io 2014. My name is Akhilesh Gupta. I'm an engineer at LinkedIn. Unfortunately, I do have a few bullet points, and my slides are not magical. Sorry about that. Just wanted to know how many of you are into mobile development? Just raise your hands. That's awesome. All right. I will talk about the concepts which are particularly talk about mobile in a little bit more depth, just to get you up to speed. All right. So I'm going to tell you a story today, and to introduce you to the characters of my story, that's me, the black little stick figure, and that green guy is my boss. So I joined LinkedIn in July of 2011, and at that point, we just had one iOS app. And it had a lot of buttons. I think it had more buttons than the main website. And the second thing was that it was really slow. It took about 6 seconds just to load the main page on the home page on the phone. So there was this attempt to redesign the entire system and to develop an app in which we could simplify it in a way that we could support all 3 platforms and that it would be fast. So we started looking for areas that we could simplify. And the first thing that we saw was that we had really complex data models on the client. What I mean by that is that something like news would have close to like 30 fields, like things like article content, description, resolved URL, all that stuff. And all this was just to display a headline and a picture of the news article. The client did not really need all this. What happened was that because of this complexity of the data model, there was serialization and deserialization into core data in iOS. So core data is an abstraction layer on the SQLite database that iOS uses. And to deserialize and serialize this data into core data, it took a lot of time because we also had to do a lot of error checks while we were doing this. So that made it really slow. We also started looking around for the types of views that our app had, and we realized that almost everything was a list. Comments was a list, likes was a list, update stream, companies, jobs, everything was a list. And the interesting thing was that there was really complex logic on the client to decide the ordering of these lists. So for example, you could have like a news article, and you would say, hey, if a news article is less than like a day old, you would put it on the top of the list. And all this logic happened on the client. And it was not really customizable. It was fixed for any user that might be using the app, and not really customized to the particular user that is viewing that particular app. So this is one problem. The second thing was that different parts of the app looked really different. And people tended to get very confused in our app because they were built by different people at different times. The navigation hierarchy was really, really complex, and people were completely lost in the app. So we started looking for solutions to these problems. And the first thing we started to look at was, what is it that the client really needs? It definitely does not need the entire news model. So what is it that we can send to the client, which would be the bare minimum for it to render what it needs to render? So in this particular example, if you're displaying a person, what you really need is a name, which can be mapped to text 1, a headline, which can be mapped to text 2, and a picture of the person, which can be mapped to a picture. So now you see that the JSON that you see on the screen is really simple. And this is really the only thing that the client needs to display a picture. So what the client can do is that it can take this template, which we describe as PT1, so that's just a name for that template. And in the case of iOS, you would have something called an interface builder file, which is the view that you see on an iOS screen. This is built using a file called a nib, which is an interface builder file. And in the case of Android, you have the views being described in XML. So you would pick the corresponding view. So the client sees, hey, I have to render a PT1. And it would go and pick the corresponding view up from either the interface builder file or the XML file. It would take the view-based JSON and plop all the data into this file. And it is able to render it. It's really simple. you don't have to figure out the complexity of the model just to figure out what goes where, because it's really well defined according to the view that you're trying to present. So that made it really simple and fast. Now, there were many more uses of this. The first one was that we were able to reuse the same template to not just display a person, but to also display a company. The person name could be replaced by a company name. The person headline could be replaced by a company headline. And suddenly, we were able to display a company in the same template that we were using for a person. So it resulted in reusability. And we did not need to ship a new client just to display a new type of data. By the way, shipping a new client on iOS takes a lot of time because Apple has a review process which takes about 1 to 2 weeks. And so it's not really as simple as just switching on new code on a web server. I also mentioned that most of our views were lists. Now that we were using view-based JSON, we were sending down the entire view-based JSON for the entire screen, which means that we were finally able to reorder the elements of this list on the server. What does that mean? That means that we were able to actually do relevancy on the server. If something is more relevant to a particular person, we would put that on the top, and you could do all that logic on the server instead of on the client. And we could do customizable logic for different users. Another thing we saw was really easy with view-based JSON was server control bug fixes. So imagine that you have a particular bug in a particular client, which is that it is unable to display company updates, and it just renders them incorrectly. Now, if this logic of displaying the company updates was on the client and it was based on a data model that it was parsing, there would be no real way to fix this bug because it is already out there in the wild, and you would have to ship a new client. The other problem is that some people may not ever upgrade, and for them, the company updates will always be broken. iOS 7 introduced auto upgrades, but before that, there was not even auto upgrades, and those people will always be broken. So what do? Well, with view-based JSON, you can actually do a bug fix on the server. The way you would do that is, since you're sending a view-based JSON for the entire screen, you would just stop sending the JSON for the company update, and the client would simply just ignore it because it doesn't really know what it's rendering. It's just rendering what it gets from the server. And suddenly, you have fixed the particular bug that the company updates had on this particular client. Now, I mentioned that we fixed it only for this client. How do we do that? How do we target bug fixes to a particular client? We do that based on a bunch of contextual information that comes in as part of the request from the client. So with every request that the client is making, it's also sending things like the OS name, the OS version, and the client version. What this helps us achieve is that we can, on the server side, we can actually have logic which is customized to that particular client. And we can say, hey, for client version 2.3, company updates are broken, so do not send them to client version 2.3. Works really well. And we're able to do a bug fix entirely on the server. Right. One of the biggest benefits, which is actually not really that technical, is that we started achieving design consistency. We saw that since we were using the same template, whether it was a person displayed on a stream, or in groups, or in contacts, we started to see that there was a consistent design pattern across the app. And the app started to look really good. Really huge for us, because previously people were like lost. They didn't know which kind of person template belongs to which area of the app. Whereas now we had a consistent design pattern. All right. So till now, we discussed how we were able to use view-based JSON to make our app simple and fast. So next thing my boss asked was, how will you make sure that it remains simple? Because every project starts that way. It's simple in the beginning, but then goes down the drain. And the next person comes in and sees, oh my God, what did these people do, right? And I was like, no problem. I'll just manually test it before every release. What's the big deal, right? Well, that process is really slow. So how do you do this? Anybody? All right, so, well, you could do this with automation. Automation, especially for mobile client development, is really, really important. All right, just wanted to know, how many of you are familiar with mobile client-side automation? Web automation? Yep, many more. All right. So it's very similar to web automation. All we're really doing is that we're getting a machine to do what a human would do if he was testing the mobile app, which is that you're automatically issuing taps, scrolls, or inputting text on the mobile app and trying to verify the results on the screen. And you repeat this process for every single scenario that you want to test in the mobile app. So there's an open source free framework called Appium, which allows you to do this kind of mobile automation testing across different platforms. And it's completely free. Anybody heard of Appium? Yeah, awesome. All right. So I'll just give a brief description and a demo. It's pretty cool to see the demo. So the way Appium works is that there is some test code, which is called the remote web driver. It can be written in a bunch of languages, which is really cool. You can be comfortable with any one of them. And it talks to a Node.js server over a JSON wire protocol. I'll actually show you what the JSON wire protocol looks like in a few minutes. And this Node.js Appium server talks to the Apple instruments in the case of iOS, and through a built-in mechanism in the case of Android. And Apple Instruments, in turn, talks to your app, either in the simulator or on the real device. So since this stuff is boring to talk about, let me actually show you a demo. Right, make this a little bigger. Right. So the first thing I'll do is start up the Node.js server, which was the second box on that slide. And the second thing I'll do is actually run it, and then I'll actually explain what's going on. So this one is doing a very simple iOS test. Starts up the simulator, starts up your app. It's a very simple app which tries to add two numbers. Now what's happening is that this test is automatically issuing commands to do this. Let's see that again. So it starts up the app, enters the first number, enters the second number, clicks on compute sum, and verifies that the sum is 7. So let's look at what JSON wire protocol looks like. So this is JSON wire protocol. It's actually a set of very nice RESTful commands. It's actually doing some very simple things. It's trying to find the first text box, which is here, and does a post to it to say, set the value to 4. The second thing it does is it finds the second text box, which is here, and does a post to it to type 3. And the third thing it does is it verifies that the result is correct, which is here. And you would see that this is very simple get and post requests. And this is what JSON wire protocol looks like. Makes it really easy to test stuff. And this is exactly how Selenium web automation also works. All right, I will go back to my slides. All right. So great, automation was set up and everything was working, but my boss is like, it's only working on your machine. Like, how will others use it, right? And I'm like, no problem. I don't really use my machine. I can just take it around to whoever needs it. Again, doesn't scale. So then we were like, okay, we need to fix this. It's really slow. And that's when we moved to continuous integration. Again, everything that we're doing is trying to make the process fast, trying to make it so that people don't have to spend a lot of time just figuring out the tools. So the way continuous integration works is as soon as you push code to your remote Git repository, there is a continuous integration system that is continuously polling for changes in the repository. And this continuous integration system, in the case of our mobile setup, is running Appium, which is our continuous integration test system. If the build passes, everything is great, it's verified, and it's ready to ship. If not, it can simply revert the check-in that just happened and inform the user about the failure. So completely automated makes it really fast and reliable. All right, great. Testing is set up. And my boss is like, I can't wait to release an update. It's a fully automated world. Everything is great. just release an update. I'm like, wait. I need to merge these 5 feature branches. I've been working on 5 different features. It all needs to go to a master branch, otherwise we can't release. Anybody done this? No? I do this all the time. All right, so again, really slow. Because then there is a person appointed as the merger, and it takes 2 weeks to merge everything. Really slow. So that's when we moved to the trunk development model. So this is the concept in which we have one branch to rule them all, the master branch, and everybody checks into the master branch. And we rely on the tests that I just described to keep it stable. And anything on master is something that we consider ready to ship. Now, the natural question to ask is, what about features in development? I don't always build my features perfectly and commit code. So for features in development, we started putting it behind a feature flag. A feature flag is basically a flag which is deciding if a new transition is so for example, in this case, it's a new animation, right? If the feature flag is enabled, your new animation kicks in. It might be half-baked. But if the feature flag is disabled, it retains the existing animation. So that means that you can do small incremental commits, like really step by step. And you don't have to break existing functionality to do that, because your new code kicks in only if the feature flag is enabled. And for even more control, I would highly recommend that you turn on these feature flags from the server. This opens up a lot of possibilities. The way this would work is that you actually have an initialization call. So the client makes an initialization call to the server, and the server responds with which features are on or off. Now, this results in a lot of benefits. The first one is that you can be on different modes on the same app. You can be in the beta mode or in the production mode, right? Beta mode would have many more features enabled. They may not be complete yet, but they let you be on the bleeding edge or on the stable version of the app with the same build. The second thing it allows you to do is it allows you to ramp new features. So for example, you're testing a new animation. You're not sure if it's good enough on a particular version of Android. You can just ramp it to a few people and see how it behaves in production. The way you would ramp it is that you would basically turn it on. You would respond with feature A equal to on only for a certain subset of your users, and make sure everything works correctly. If it does, you ramp it to everybody. Makes it really, really, really simple to test new features in the wild. All right, so now we have a CI system set up with a single master branch. Everything is great. And this time my boss is sitting on the developer console, and he's like, I can't wait to press the release button. And again, I'm like, wait, I need just one more day to finish my animation. It's really good. I want it to be in this release. And of course, I'm a bad coder, so 1 week becomes 2 days, 1 day becomes 2 days, and 2 days becomes a week. Again, really slow. So how do we solve this? People always want to ship that one more thing in every release. And we realized that our ship dates were slipping. Like instead of a particular day, we would always ship like 3 weeks later because this one more thing needs to go in. So that's when we moved to the coveted train model. The train model has fixed release dates. Your releases happen on a fixed day and a fixed time, which means that everything is pre-planned. And whether you're inside or outside the train is going to leave the station, right? So either you make the release or you don't make the release. So team has to either fully develop and test the current feature for the current release, or it has to wait for the next release. And you cannot really stand in front of the train and stop it. It's too big. You're going to die. So that forced people to make sure that they're targeting a particular release. And instead of trying to stop a release, they're pre-planning to make sure that the particular feature can happen in a particular release. Now, this had huge benefits. We knew exactly when we'll ship. It became predictable. It became fast. And teams started planning their scope and their development cycles according to this release schedule. And we always knew that we would ship on a particular day, which is amazing. Like, everybody's happy. Your managers are happy. Your product managers are happy. Your bosses are happy. Everybody's happy. Makes it really easy. As part of the trade model, we did another thing, which is that we decided to decouple client and server releases. So server releases are like bullet trains. There's nobody to stop them. But on the client, especially on iOS, every release is gated by Apple. Now, Apple can take any amount of time. Sometimes they take a week, sometimes they take 2 weeks. You have no idea, right? So then we decided that these two are separate entities and we should treat them as such. And when we did that, we were able to release the server twice a day, and we were able to release the clients once a month. And we got into a very nice cadence. Now everybody knew that the server is going to ship every day and the client is going to ship every month. Makes it very predictable again. So on the topic of releases, I also want to talk about alpha and beta testing. Now, most people might think that, hey, alpha testing, beta testing takes a lot of time, slows down the process. But it's actually the other way around. The more you do beta testing or alpha testing, it can actually make your development really fast. And you spend less time fighting unexpected problems. So in iOS 8, there's a brand new feature called test flight, which is for beta testing. And it allows you to do 1,000 beta testers simply by their email addresses. On Android, this has been there for a long time, and it works really well. So I'm just actually going to take you through how it works on Android. The tools are really nice. So the way it would work is that you would select your executable that you want to test with your beta testers. You figure out a Google Plus group of beta testers. Anybody knows what Google Plus is? Cool. All right, so you basically have a group of testers, which are your beta testers, and you publish the new executable to them. They try out your APK. APK is, in the Android world, is the executable that actually runs in a phone. And you start collecting feedback. And you iterate on this till you're satisfied with it. And finally, what you do is something interesting, which is called the production staged rollout. So I'm going to talk about this because this is also really useful. So what a staged rollout means is, it's amazing. This happens a lot. You release an app, and you realize that it's crashing on like this particular version of Android, which is running in a particular country, and crashes like after 2 seconds after opening the app. Happens a lot. Now, there's no real way to test this because you cannot possibly have all the Android phones in the world unless you're a billionaire. There's just so many. So what this allows you to do is do a staged rollout. So you can do something like releasing it to 5% of your total user base. And then you can start monitoring reviews. You can start monitoring crash logs. You can start figuring out if there are any problems with the new executable that you just released. If there are problems, you overwrite the executable with the new one, with the bug fix release. And you again go back and release it to 5% again. You keep doing this till you're confident that everything is great. Once you are, you go to a 10% release, and you repeat the process. And this really allows you to make sure that by the time you reach 100%, your app is good to go. You have figured out that there are no crashes. You figured out that the reviews look good, and everybody's happy, and it's not crashing on a particular Android device, which you don't really know about. So this allows you to really breathe easy, something that I would highly recommend. Unfortunately, there's no staged rollout support on iOS, but you can still do a lot of beta testing. One is the test flight thing that I just mentioned, and the other is that you can make use of something called enterprise signing, which allows you to release your iOS apps within your company. And anybody can use it and install it. It's a very simple process. You just sign up for an enterprise account, and anybody within your enterprise can install the app. And of course, there are a bunch of third-party solutions which also work really well. So please use them. All of these things result in happy customers, and you don't want angry reviews on the App Store. They can get really, really bad. You don't want to read some of the reviews that I've personally received on some of the apps that I've shipped. All right, so all of this actually results in a faster development cycle, so please use them. Since we're talking about monitoring, one other important thing that I just mentioned was crash monitoring. So there are a number of good tools that you can use, and it doesn't really matter which one. All of them serve most of your purposes. You should obviously test ride them and figure out if it serves your purpose, but there are many good ones out there. Criticism, Crashlytics, BugSense, all of them do really good crash monitoring. It really helps to be on top of performance issues, really affects the quality of your reviews, so really important stuff. All right, I'm going to switch gears and talk about something that I mentioned in passing, which was that we release the server twice a day. So that means that if I'm pushing code right now, it would be in production in less than 3 hours. Now that's really fast. And to me, that's really scary because I write really bad code. And I was like, this is too scary. So how do we do that? How do we make sure that something that's actually good is getting to production within 3 hours? So we do this with extensive integration tests. But before I talk about that, I'll try to give you an overview of the system. So at LinkedIn, we have a Node.js server. And this server basically serves three apps, flagship apps. One is the iPhone app, the second is the Android app, and the third is the mobile web app. And this server talks to a bunch of downstream services to serve all the data that I was talking about. And the server is the one responsible for capturing all this data from the downstream services, converting them to view-based JSON, which I spoke about earlier in the slides, and serve this to these mobile clients. So integration testing. It's very similar to the client-side automation that I just spoke about. The difference is that we're trying to test a server. So the way we do that is we're making sure that every route on the server is working correctly. So we want to exercise all the routes, and we want to make sure that the responses are accurate. So when we implemented this, it took about 30 minutes to run the tests on all the routes. Really complicated. And there's so many different routes that the server exposed. And we realized that most of the slowness was because of how slow certain downstream services could be. And sometimes they would be unreliable, like certain things would fail, which caused our tests to become really slow. Even though we're not actually testing downstream services, we are testing the server. We're testing the mobile server. So what we figured out was, like, what if we could record the responses from these servers into a file, which we call fixtures, and then play back the responses while doing tests, because the downstream service responses don't really have to change, and they don't really have to be live. And if you play back those responses, the tests can be really fast. So this particular concept is actually pretty common, and there's a popular module called VCR, which lets you do this. It's an open source GitHub module, and it supports many HTTP libraries to do this on the fly, and it's really useful. At LinkedIn, since we were using Node.js as our mobile server, we actually built a VCR-like module for Node.js, which is called Sepia. And others are very similar to this. So just to show you how this thing works, I'll again do a brief demo. Right. So in this particular case, let's look at an example. So you don't need to worry about actually what this code is doing. I'll actually explain that to you. So this is a simple Node.js HTTP server, and all it does is that it reverses the header that is being sent in the incoming request. And the other thing it does is it uppercases the body. So that's all it does, very simple stuff. And this particular test is trying to test that. It sends in a header called hello, and it sends in a body, which is hello world in lowercase. So let's see what happens when you run this. Okay, so Node.js, you're running the server that I just described. So it reversed the header that was sent to it and made it OLLEH, and it uppercased the body. And the time it took to do that was 510 milliseconds. Now let's start using VCR, which is the Sepia module that we developed for Node.js. So the first thing we would do is run this in record mode. Record is actually taking the downstream response and recording it in a file. So you would see something like VCR_mode equal to record and examples/http.js. Now, this is the thing that happened here is very similar to what happened before, and the time it took is also similar. But the other thing that happened is that it generated fixtures. So let's look at these fixture files. So in this case, it has actually recorded the response of the server, which is the uppercased hello world. And it has also responded all the headers that the server would respond with. And all of this is recorded in a file. Now, the next thing you can do is actually run this test in playback mode. And when you do that, you see that the time it took to run that was 2 milliseconds. Now, although this is a very small gain in this particular example, imagine this happening for every single test that you're running on your server. It would make it super fast. All right, let's go back. All right, so that was Sepia. Makes integration tests really fast. So when we started using it and we started to run all these tests parallelly, we went down from 30 minutes to 15 seconds to run all of our tests for all the routes that we had for our mobile app. It became so fast that we were able to run them as part of our unit tests and part of our pre-commit tests. So this is happening at the time of your commit, which makes sure that anything that's going into master has already passed all your unit tests and has passed all your integration tests. It's good to go. All right, since we do have a few minutes left, I'm going to talk about one more thing, which is A/B testing. So one of the biggest benefits of view-based JSON that we started to realize as we were doing more and more product development was that we were able to actually do A/B testing very easily. So let's see how we achieve that. So let's say you want to A/B test this. You want to A/B test the fact that like as an icon or like as a text, which one works better? So one way to do that is that you serve like as an icon to a certain set of users and like as a text to another set of users, and then try to figure out which one is performing better. And you could use metrics like click-through rate or page views to make sure that one of them is performing better over the other. So this process is called A/B testing. It's really common on the web, but it's very new to native apps, very new to mobile native apps. So the way you can do this is that there are a bunch of A/B testing frameworks that have recently sprung up for mobile. A few of them are listed here: Optimize, LeanPlum, Arise. They're all great startups. The way they do that is they either allow you to make multiple versions of your app and upload them and then decide which version of the app gets shipped to different people, or they provide you SDKs which allow you to tweak colors, fonts, and stuff like that on the fly and actually deploy it to a certain set of users. They also allow you to tweak certain parameters in the UI, which you can actually use in your code and decide whether you want to present UI1 or UI2. So all of this is how these frameworks work. What we realized at LinkedIn was that view-based JSON actually makes this process really simple. So imagine that a like is based on something called a social action template, which is similar to the templates that I was describing above in the previous slides. So in one case, you could say that, hey, when I say that the view type is sat1, the mobile client should pick up the view-based template for social action template 1, which is the like-based icon. And when the server sends SAT2, it would pick up the view-based template for like as a text and show the text like. Now, this makes it really simple because the client is actually not really involved in this A/B test. It's the server that's doing it. The server just says, use SAT1 for this set of users, use SAT2 for this other set of users. The client simply goes to its list of templates, picks up the right template, and renders it on the screen. It has no idea that it was just A/B tested, right? And all of this logic, the complex logic of doing the A/B test, resides on the server. So if there are bugs, you can fix them on the server. You don't need to worry about shipping a client which is showing wrong versions of the A/B tests. Makes it really simple. I describe this process in even more detail in one of my blogs. So if you're really interested, you can talk about it. You can actually see it. But in general, the benefits of this is that you can target the A/B tests simply because of the fact that you have the contextual information coming from the client anyway, and you can use that to say, hey, I'm going to A/B test this particular feature for English users in the US, or A/B test this particular feature for Polish users in Poland, because you have all that information coming in from the client. And the A/B testing decisions are happening on the server. And when you've figured out that a particular test is performing really well, all you need to do is start serving that template to all your clients. So deploying it to everybody also becomes really easy. And you can also, of course, move users between buckets freely by simply serving them different templates than what they were getting originally. So no client iteration is required, and the full control is on the server. Right, so we spoke about a lot of things. So if you have any questions, I would love to take them. And the mic is on the center there.
Hello, is it on? Okay. I'm Bob King. My question is for your mobile development. Do you have members that work across all devices, or are they specialized teams? Also, I noticed you have a LinkedIn app for the Windows Phone, but I didn't see it on your slide. Is that part of the process as well?
Sure. So when we were small, which was about 2 years ago, we actually had client-side developers working on across different apps. When I started, I actually used to work on Android, an iPad, and the iPhone at the same time, which is interesting. But now, as we are becoming big and more and more of our traffic is coming through mobile, we actually have dedicated teams for Android development and iOS development. Having said that, people do actually move around a lot because client-side development is very similar, whether you're doing it on Windows Phone or iOS or Android. The languages are different, but the concepts remain the same. So people do different things all the time. Windows Phone is definitely part of our portfolio. It is not as central to us as iOS and Android, but we do maintain it, yes.
Hi, I had a question about the feature-based flags that you use.
Mm-hmm.
Do you, or what is the process for actually like retiring those flags, or how do you decide when it can be removed, or I guess, how does that work?
Very good question. So feature flags are in two places. One is on the client and one is on the server. Let's talk about the client first. The ones on the client are actually shipped with the client. You can never remove them. They're just gone. But what you can do is, if you realize that a particular feature is fully ramped, and you're never going to take it away. For example, if you introduced company updates into the stream, and they're part of your product, you're never going to take it away. And once you've made sure that it works on all clients, works great, that's when in the next release of the client, we would just remove the feature flag. So that, because it's part of the product. It's not being tested anymore, it's not being ramped anymore, and we're not worried about the server loads and stuff like that. So that's what you would remove it from the client. On the server side, we do have a lot of feature flags simply to do A/B tests or to ramp different features. This is something that we regularly clean up because server code is something that we are shipping twice a day, as I said before. And therefore, we do have a process to make sure that anything that's fully ramped and fully tested, we go and get rid of it.
I had a question about the testing that's involved for sending out, right before sending out the server. Who's in charge of writing those tests and making sure that they're still accurate and testing something and not become basically void or just not applicable?
Very good question again. I'm glad you asked this actually. So the way it works is that every single change that you're making to a server, to server code, the person responsible for the change is also responsible for writing the test. We do not have a separate test team to say. Yeah, so anybody who's checking in code to the server side is also writing the test for it. And the way we make sure that that is happening is through review boards. So every code before being checked in is being reviewed by one of your peers. And he's the one who is holding you responsible for things like, where is the test for this? Or have you tested this fully? Or if you have tested 3 particular scenarios, he might come up with 2 more and say, hey, did you test these 2? So based on these review boards, we are actually making sure that the person writing the feature is also writing the test for it, and they get checked in as part of the commit.
Yeah. You mentioned in your slides how important it is to do performance testing for mobile development. I was just curious if LinkedIn does anything or is looking into anything for like automated performance testing for your guys' mobile apps.
So I think performance testing is one thing which is still not completely automated. The way we do that is some of these frameworks actually provide you like page load times and stuff like that. But again, they've never turned out to be sufficient, at least in my experience. So performance testing is still pretty manual. I personally don't have a lot of experience with it, but I can come back to you on this after speaking to somebody else in my team, because there is a specific set of people which are worried about performance in mobile. I can come back to you on that, but not a lot that I know about. Yeah.
Can you briefly describe how you select those subjects that you that you pick for A/B testing? And then secondly, how do you test server code? Say you have to hit a certain endpoint that may not be implemented in your current server infrastructure. Maybe you're writing a new service in a different language or different technology.
Okay, so let's talk about the second question first. So the way we would, I think if I understood your question correctly, you want me to tell you how we are testing server code that is still in development, right? Like it's not completely done yet, it does not really perform what it's supposed to do, so how would you test part features like that? So the way that would work is two ways. One is that we're writing unit tests for the server. So unit tests would simply cover all the small functions that you're writing in the server. In our particular case, we are using Node.js. So it would actually test any kind of logic, any kind of processing that the server is doing. And we would mock out all the downstream requests using something like Mockito or Mocha. And that would take care of the functional aspect of what the server is doing. The other aspect is the integration test, which is the server responding with the right data? Is it actually succeeding on in this kind of request, or is it failing on that kind of request? Yeah.
I think what I actually meant was, how do you handle A/B testing when you require different server logic, a different response, if you will?
Oh.
Set of APIs that may not be available in a previous version of your software.
On the server side or on the client side?
Well, say you turn on a feature flag on the client side that
Okay.
requires a certain API to be available.
Okay.
Do you roll that out along with the server? Do you have another server set up where you route requests based on the customers you've selected for these tests?
Oh, good question. No. So any A/B testing that we are doing is actually happening on just one code base for the server. And that same code base supports both the A part of it and the B part of it. The only difference of how it actually is deciding whether to serve A or B is actually through a downstream request. Okay, I'm actually going to talk to you about it offline because we are out of time. But thank you so much, guys. I have most of this, what I spoke about, on our engineering blogs, so you can actually go and take a look. All the best. Thank you so much, and be lightning fast.